Hello friends, welcome to another video of related to electrical and electronics engineering. So I am Sujay Saha, Associate Professor working in basic sciences that you already have seen my videos. So to be frank that here we are working on circuit analysis techniques, and we have just learned about source transformation. Source transformation in our last videos. So now we will get to know about so we have learned about source transformation and theory and its application. So we have done some problems. So now today we are going to see another technique called nodal analysis for simplification and try to understand that how this technique can be used for simplification of any complex circuitry. So let us start. So like nodal analysis, it provides a general procedure of analyzing the circuit using node voltage. So what is node, what do you mean by node and all that will just come to in another 10 minutes. So this is basically a general procedure, it's nothing new. Okay, so now choosing node voltage instead of element voltage as circuit variable is a convenient way. Like you don't have to worry about the individual, like there is a resistance R and there is another source here. Now if you have another branch somewhere, like some extra branch is here, some extra branch is here, so you need not to worry about the individual drops across the circuit elements. We have to work about the nodes. Now what is node, we will come to know in another 10 minutes. Okay, so now this reduces the number of equations. Like you have, if there is like 10 elements, so probably there will be less than 10 node in a circuit, and that will reduce if we can determine the how many node is there, and we can determine the nodal voltages that time, and then we can reduce the equations involved. So let's say for circuit element has so there are 10 circuit elements, so you probably need to solve 10 equations for say, and then if there is only in the circuit there is only 3 nodal 3 nodes are there, and then the variable, the circuit become only equation of 3. So instead of 10 equation, now you are going to solve only 3 equation, and which is at least easier than to solve 10 simultaneous equation. Okay, now step to determine nodal voltages is, now select a node. Now we have to always, for nodal analysis, we have to determine first the reference node. With respect to, we will be determining all the voltages. So usually the reference node will have V0, the voltage of the nodal of this reference node. With respect to all the other nodes will be all the other nodal voltage will be determined is taken as 0. So we can say this is something we will assume that okay, the reference node is at 0 volt. May happen that for some reason that it may happen, there are many any advanced problem, you might see that reference itself is not at 0, but with respect to reference every other node is having some other different larger voltage, so which can be which is convenient sometime, because what we are doing nothing but a mathematical analysis of the circuit. Remember that circuit analysis is nothing but algebra. It's a pure algebra. There is nothing, no other tricks are involved. So it's purely mathematics, and in mathematical sense you can have a node voltage V0, and with respect to there might be several other voltages having V1, V2 and V3. So it can be possible that you have several other nodes having different voltages, but V0 you can say that it is at 0 voltage. So it may happen that it is not at 0, it might be at 2 or 1 also. but the other with respect to this is at 3, this is at 4, this is at 5. So V3 is 5 minus 0 equal to 5 voltage. It may happen that it can be a different. It may happen that this 0 volt instead of 0 it is 2, and that time if it is 5, then obviously the obvious reason this actually is not 5, it will be at 5 plus 2 7. Okay, so for time restriction, we can still believe or still assume that this V0, the reference voltage, is at 0 voltage. Okay, now we can assign the other nodal voltages as V1, V2 up to Vn minus 1 for the remaining n minus 1 nodes. So 0, this 0th node, the 0th node is actually the reference node, and the 1, 2, 3, 4 up to Vn minus 1 remaining at the n minus 1 node. So you will have n nodes where V0 is the first node or the reference node, other one are n minus 1 node. Okay, now we always calculate the voltages are referenced with the respect to the reference node. What I was saying that with respect to reference node, all the voltages are being referenced. So if it is reference voltage is 0, so we will determine, we can easily calculate that easily determine the V1. If it is 2, then it's exactly at 2 volt for say, and for V2 will be 2, 3, 4, whatever we determine. We'll come to some numerical problem, then only we'll get to understand completely what is happening. Now we will apply KCL. We will apply KCL in each of n minus 1 reference nodes. So each node, so let's say for a simple example, you have this kind of circuit. So what are the nodes, we will find out, and we will apply the KCL at the node. So now node, what to mean by node, that will come to in another few minutes. So we'll express, we'll have n minus 1 for n minus 1 node. So if there are like reference node and 2 other node, we need to only solve that 2 non-reference nodes, and there will be KCL equation, where there will be KCL equation at this n minus 1 nodes, and then we'll solve. Okay, and simply we will use Ohm's law. So there is no other thing. Solve the resulting simultaneous equation. If there are n minus 1 equation, we will solve those equation, and we will calculate the unknown node voltage. So this is basically some theory. So let us go to a particular example of the circuits. So here we have a typical example of a circuit. Okay, so here we have a current source having I2 current, a current source having I1 current, and these are 3 resistances and having some voltage drop across each of them. Okay, now we look at the circuit. Now what is node? Node is where any 2 circuit element or number of circuit element, they meet at some junction. So those are called node. Okay, so if any point in the circuit where a number of circuit element joins, those points are called nodes. So node, we can say that, so a point where multiple circuit element meet. Circuit elements meet. Okay, this is very crude definition, but still we can use this one for our understanding. Okay, so first of all we need to have determine the datum node or the reference node. Reference node is sometimes called the datum node. It is some word, but we will always use the word of reference. Okay, reference node. We will see. So now look at this circuit. So it has 1, 2, 3. So it has how many? 1, 2, 3, 4 and 5 circuit elements. Okay. Now you can see that this I1, this circuit element, this I2 current source, R1 resistance, R2 resistance and I1 current source is meeting at a junction of 1. This point is named as point 1. Okay. Now this is another point where this current source R2 and R3 meet at this junction. Okay. Now this particular point is not a node. Why? Because this is a simple wire. Okay, this is simple a wire, and wire does not have any resistance as for ideal circuit analysis. So this point and this point, they're actually the same point, right? Also this point and this point is also actually the same point. So you cannot say this is a node or this is a node. Here no other circuit element is merging at this point because these 2 points are actually the same, right? So 1 and 2, these are actually the node in consideration. Okay, now look at the bottom. So here at this 0th mark, this I2 current source, this R1 resistance and this R3 resistance, they meet at this junction. Remember that for the same reason, this point and this point, they are not a node, or they are not actually a junction. The junction is here because R3 and R1, they meet at this point. I2 current source and R1 resistance, they meet at this point. So actually this is a node, right? So for any circuit element, for any circuit analysis, we always choose some node which is at the very downstairs, and you can choose any other node as your reference node, but where the most number of element meet, that point we say as our reference node, right? So it may happen that there might be more number of circuit elements are meeting at other junctions also, but for sake of simplicity, we can, for this particular problem, we can choose this our reference node. We can choose this as our reference node, no issue, but we are choosing this our ground. That is something we are choosing. So this is something our reference node. This is our reference node, and we'll take this as a reference node, and the voltage at this reference node is chosen to be 0. So with respect to this particular node, all the other nodes will be 0. Now you can think of to rotate this circuit by 90 degree, then this probably become the node, right? So this is up to you, which one you are choosing as your node, that is up to you, but we, for simplicity, for this reason, this is 0. This is the 0 node, 0th node, or the reference node, correct? Now, so reference node, this reference node is commonly called as the ground, since it is assumed to have 0 potential, because like ground has, the earth has 0 potential, we know from our basic knowledge. So reference node, we assume that this is V0 equal to the V0th node equal to 0 voltage. That we assume. This is our assumption. Okay. With respect to it, all other node voltages we will determine the voltage of all other nodes. Okay. Now once we have selected the reference node, assign voltage designation of the non-reference node. So we have determined, so this is V0, taken to be a 0 volt. Now there are 1 and 2 nodes, so this is V1. At this particular node, the voltage of 1 is V1 and this is V2. Okay, now we as V1 and V2 respective. Okay, now keep in mind that node voltages are defined with respect to the reference node. This is always with respect to the reference node. Now if the reference node is at V0 equal to 0, then whatever V1, V2, they will be at their absolute values. If V1 is not equal to 0, then probably we will simply add up to how much voltage is that. So that is something, but for sake of simplicity, we always take V0 equal to 0. Now each node voltage rise from the reference node to a corresponding non-reference node, or simply the voltage of the node with respect to the reference node. So this is the one we were talking about, that if it is V1 is the voltage of the non-reference node, then this is V1 volt higher than the reference node that we assume, and that is we will determine. Okay, so this is the technique, correct? Now okay, so in the second step, what we are going to do is to apply KCL at the each node that we are going to apply. Sometimes in many books you could find that apart from reference node, the reference node what we are taking, apart from that, the other nodes are also called the principal nodes. Principal node, or you can always say that's non-reference node, you can say. Okay, so this is something we need not to remember, but you can just for sake of time being, you can just have a name. Okay, so that's a non-reference node. Okay, now from non-reference node, it is always mandatory to apply KCL at this non-reference node. Okay, so we know that at V1, at this node number 1 and node number 2, the voltages are with respect to the reference is V1 and V2. So at node 1 we apply KCL at point 1. Okay, so we will apply KCL. Now you can think that there is one current source which will be obviously going in this direction. For obvious, this is this direction, and the current we choose that I1 will be flowing from 1 to reference node, and I2 is going from 1 to this 1 to 2, and the other current, this I2 is also going away from the node. This is something we have seen from our own idea, that at 1 there are 4 currents actually, namely 4 currents. I1 is coming towards point 1, I2 currents going away from this node 1. We assume that from 1 to reference there is a current small I1, and from 1 to 2 there is a current small I2. So KCL we apply, and we know that KCL is the the amount of incoming current will be equal to the amount of the outgoing current. So I1, this is incoming current, which is equal to I2 plus small I1 plus small I2 at this point. Okay, so this is very reasonable to understand that, okay, what we want to do. So this is I1 which is coming in towards this is I1 coming towards the junction 1. Small I1, that is our assumption that there is some current flowing from point 1 to the reference. It may be 0, it may not be non-zero, but there will be some current. We are assuming that each branch has a current. Now there is another current going from 1 to 2, and which is small I2, and another current which is obviously seen in this circuit, which is capital I2. So incoming, this is incoming current, and these are all outgoing current. Okay, this is at 1, this is at 1, this is at 1. Now at 2, at this point 2, here also we assume that from point 2, from node 2 to the reference, I3 current is flowing, I2 current flowing from 1 to 2, which is same as here, and then capital I2 current is coming towards the point 2. So just see that which one is outgoing, which one is incoming. So here the incoming current is capital I2 and small I2, which is incoming current, and the outgoing current is I3, right? So incoming current is I3, outgoing current is I3, and incoming current is I2 plus I3. Now we are at the same, this is something which is now very obvious. Now we apply Ohm's law. Now we apply Ohm's law to express the unknown currents, right? Now current is something, current is V equal to I equal to V by R. Now this V are the nodal voltages. We will express this V as nodal voltages, right? So now we apply Ohm's law to express unknown currents I1, I2, I3, which is we don't know. I2 and I1, before beginning of the problem, I2 and I1 was known. What we have assumed, what we have taken into consideration, that I1, I2 and I3, these are unknown currents that we need to determine. Now, since the resistance is a passive element, by passive sign convention, current must always flow from higher potential to a lower potential. Okay, so always, like for this R resistance, the current will flow from a higher voltage to a lower voltage. Now for this R1, the current R1 will be equal to the higher, now current is flowing from higher voltage to the lower voltage. So we have assumed that this is 0, and we assume that V1 is not equal to 0, and which is higher than 0. So it will be obviously V1 minus V0 by R1. So which is obvious, V1 by R1 as V0 goes to 0. Correct? So all current will be equal to V higher minus V lower by resistance R, right? So this is something we have to determine. Now the third step is to solve for the nodal voltage. Now we have, now this I1, this is R1, this current is equal to the V1 by R1. So there will be several others too. For I2, you can say that what is I2? I2 is flowing from V1 to V2. So higher potential is V1 minus lower potential is V2 by R2, and I3 will be equal to V2 by R3, because V2 minus V0 by R3, and which is equal to V2 by R3. Now this equation, the simultaneous equations are like there are 3 unknown quantity, we have 3 equation, and we can solve them. So this is something we need to like determine, and this is I1, I2, I3, this we know. Now we club in. Now we don't know what is I1, I2 and I3, and also we are not very much into what is V1, V2, V3, V1 and V2, which is also we don't know. But what we know is I1, I2 we know, so we can club this I1 and I2 and I3 in terms of V1 and V2 into this equation number 2 and equation number 1. So we can club this expression for I1, which is VR1 is nothing but I1. So this is basically I1. So we can express I1 in terms of V1, I2 in terms of V1, V2, and I3 in terms of V2, and we can club this formula into this equation 1 and 2, and then we can express the equations in terms of V1 and V2, right? And then again we have to solve for node voltage, and we get V1 and V2, and that will be our job done. So let us say we try something. So here also the same way we'll do that. I1 equal to V1 minus 0. So I1 equal to V1 minus 0 by R1, or I1 equal to G1 V1, where we assume that, where we see that this R1 by R1 equal to G1, the conductance. We know that the reciprocal of resistance is conductance. We express in that way because reciprocal quantity is not very much easy to handle with. Okay. Same thing, I2 is V1 minus V2 by R2, or I2 equal to G into V1 minus V2. Same thing, 1 by R2 equal to G2. Similarly, I3 equal to V2 minus 0, I3 equal to this V2 minus 0, which is the reference voltage V0 equal to 0, by R3 equal to I3 equal to G3 and V2. Now we know that in our equation number 1 was I1 equal to I2 plus small I1 plus small I2, and I2 plus small I2 equal to I3. Now we club these things into, we express I1 and I2 and I3 in terms of V1 V2. So this equation becomes I1 equal to I2 plus V1 by R1 plus V1 minus V2 by R2. So basically the expression for I2 and I1, correct? Second equation becomes I2 plus small I2 is V1 minus V2 by R2 equal to V2 by R3. Okay. Now in terms of conductance, we can have this equation I2 equal to capital I2 plus G1 V1. This is, we are clubbing this expression, and this is the 2 equation. Okay. Now we can rearrange, we can simply rearrange this into a matrix form, like A1 B1, A1 X1 plus A1X plus B1 Y equal to C1, and so this simultaneous equation we can have. So we can, let's say we can just simply give it a shot. So we take common as V1, then G1 plus G2 minus V2 G2 equal to I1 minus I2. That's equation number 1. And then we can take it here. So this is V1 G2, V1 minus, we are taking this into, on the left hand side, we are taking this into right hand side. So minus V1 G2 plus V2 equal to G2 plus G3 equal to I2. So now you can see that this is something, these two simultaneous equation in variables are V1 and V2. So obviously in a matrix form we can write down. So G1 plus G2 minus G2 and minus G2 divided by G1 plus G3 equal to V1 V2 equal to I2 minus I1 and I2. This is the in a matrix form. But you don't have to write down in a matrix form. You can simply, these will be numbers actually, and those numbers you can solve by hand. No need for this matrix formulation. But this becomes convenient when there is more than 3 or more than 4 or 5 terms will be there. Now you need a computer program to solve it for determine for matrix during some matrix algebra. You can simply do that. So for normal practice, these will be numbers, and numbers will be like simple like kind of basic numbers. There will be no imaginary or something, so that we can solve it easily by just using a calculator or using any other method. Okay. So now with this we thank all of you to to be here and give very like support to me. And once again I congratulate all to seeing this video, and if something you learn, then give me a like and also subscribe to my channel, and then we'll come to our next problem solving by nodal analysis. Okay, till then, thank you.